Alright, so in this video we're going to discuss the Carnot cycle. And the Carnot cycle is supposed to be the cycle with the greatest possible efficiency. And how this works is by using reversibility. Now, when we talk about something being reversible versus irreversible, most things in life are actually irreversible. You drop a teacup and it shatters, and it is not going to spontaneously put itself back together. So when we talk about thermodynamics, energy flows from hot to cold. It's not going to flow from cold to hot without putting work into the system, as we saw with refrigerators. So in order to get something to be reversible, we actually have to do it isothermally, where there is that ability to go frontwards and backwards because you don't have a hot or a cold temperature. So when we draw our pressure versus volume graph, A to B isothermally, and then from B to C adiabatically. So here we have QH and TH, and then we're using the adiabatic expansion in order to actually change the temperature, so that now we're at QC TC. So now once again we are isothermal. And then we adiabatically return to the original temperature. So in order to calculate the efficiency of a Carnot cycle, we would use 1 minus temperature cold divided by temperature hot, or we can use the idea that TH minus TC is O over TH. We can also calculate the coefficient performance for a Carnot refrigerator using temperature cold divided by temperature hot minus temperature cold. And even with these types of theoretical maximum efficiency engines, we find that we cannot get 100% efficiency. And this is going to turn out to be related to what I talk about in the next video, where we always have to expel heat in order to return a certain value back to its original thermodynamical state.